Hello everybody. In today's class, we'll discuss about the topic from the fourth unit, that is resistors. In the previous classes, we have been discussing about PCBs. So we have discussed the different types of PCBs and the main components of PCBs, and PCB manufacturing process has been discussed in detail in the previous videos. So these PCBs hold the components which we design as an electronic circuit. So one of the basic electronic component that we generally use is nothing but resistors. So in any electronic circuit, we find this as a basic component. So the basic component which opposes the flow of current is called as resistor. So in Ohm's law also, in the class of Ohm's law and its limitation, we have derived an expression relating voltage, current and resistance. Okay, so in that what we have discussed is voltage is directly proportional to I into R, where voltage V is in volts is given as current I in amperes into resistance, that is in ohms. So there itself we got to know the term resistance. So in this video we'll try to know some more points regarding resistors. The point to be noted here is that the resistors form the basic component in any electronic circuit. So let's discuss some of the points which relate or which will get to know about resistors. So in this video, the learning objectives will be: what is resistor and what are the types of resistors, and what kinds of basic connections that we do for resistor will be discussed in this video, and resistor color coding as well as resistor power rating will be discussed in this video. Okay, now let's start learning the first point, that is what is meant by resistor. So resistor is nothing but a passive two-terminal electrical component that implies electrical resistance as an circuit element. So that is nothing but passive. Passive is nothing but which does not act as an energy source. Okay, those kind of components are called as passive components. So for any resistor we see two terminals, and that resistor is a passive kind of component. And the other point regarding resistor is that resistor is bilateral element. Bilateral, that is the passage of current from any of the terminal will remain the same. That is, here the polarities like positive and negative, what we have seen for batteries, that is like for anode we take it as positive, cathode negative. Those points are not there for the resistors. That is, any of the terminal can be considered as positive or negative. That is, actually no positive negative connections, polarities are prescribed for resistor. So you can use those two terminals anyway. So the resistor is simply called as a passive bilateral two-terminal electrical component that implies electrical resistance as a circuit element. So the ratio of voltage applied across the resistor terminal to the intensity of current to the circuit is called as resistance. So according to Ohm's law, what we know is V is directly proportional to I into R. So from this expression, we get to know the value of R as R is equal to V divided by I. That is, the amount of voltage which is applied across the resistor terminals and the intensity of the current that is flowing between the terminals of the resistor will give the value of resistance. Okay, so R is equal to V by I. So that is nothing but that is the expression what we give for resistance. And coming to the unit and symbol, in general, the unit of the SI unit of electrical resistance is named after the scientist George Simon Ohm. So the unit for resistance is given as ohm, and the symbol is this one. What is it is here? This symbol, inverted U kind of thing. That is, this is the symbol of resistance. So unit is ohm, named after the scientist George Simon Ohm. So an ohm is equivalent to volt divided by ampere. That is nothing but, just now I have told you that R is equal to V by I. That is, unit of voltage is volt, and the unit of current is ampere. So the unit of resistance is ohm. So ohm can be written as ohm is equal to volt divided by ampere. So another for the ease of calculation or ease of notation, the other units what we can write for ohms are milliohms. 1 milliohm will be equal to 10 power minus 3 ohm. Here m what here it is capital, but this is not capital, small. 1 small m ohm is nothing but 1 milliohm, that is 10 power minus 3. Kilo ohm means nothing but 10 power 3 ohms. Mega ohms is nothing but 10 power 6 ohms, like what we see for milli, mega, micro, nano. So everything applies to the resistors also. So coming to the symbol of resistor, so this is nothing but the, in general we see two main types of resistors. One resistor is fixed resistor, that is the resistor whose value is fixed and it cannot be changed according to the circuit parameters. That kind of resistor is called as fixed resistor, whereas some resistors are available in which we can change the value of resistance according to the circuit parameter changes. So those kind of resistors are called as variable resistors. So as of now we got to know that there are two different types of resistors. So that's why I have given you two different symbols for resistor. The one without arrow, which has two terminals and a zigzag line between the two terminals, is showing us the symbol for the fixed resistor, whereas the two terminals and in between the two terminals a zigzag line, and on that line if we have an arrow, that kind of resistor is nothing but variable resistor. So this is a symbol for fixed resistor, this is a symbol for variable resistor. Okay, and coming to the, as of now I have told you that we have two different types of resistors. So we'll see before going into the other points. So first we'll see what are the different types of resistors that are available. So any resistor is mainly classified into two types, fixed and variable, and depending upon the type of material what we use for the construction of the resistors and its mounting type and other parameters will decide or will give us another different types of resistors. But the basic classification is fixed and variable resistors. So in the fixed resistors we have four different types of resistors that we can observe on the screen. The first one is carbon composite resistor, next one is film resistor, wire wound resistor, resistance wire resistor. Okay, so these are the 4 different types of fixed resistors. Coming to the variable resistor, we have rheostat, the most commonly used one. Next one is potentiometer, thermistor, humistor, varistors and photoresistors. So all these resistors, the functionality is the same. So the resistor, what does it do is it opposes the flow of current. So resistance is nothing but opposition to the flow of current is called as resistance, and it is denoted by a letter R and indicated by a symbol zigzag line if it is a fixed resistor, and on the zigzag line if there is an arrow that indicates a variable resistor. Okay. So all the resistors, either it may be fixed or variable resistor, its usage and its functionality is one and the same. Depending upon its value, it offers some resistance to in the circuit that it is connected. So the amount of current will be flowing in the circuit will be inversely proportional to the resistance. So according to the Ohm's law, what we can write is V is equal to IR, R is equal to V by I. Here we can observe that R is inversely proportional to current. So more the resistance, the lower the current, and less the resistance, more current will be flowing into the electrical circuit. So the resistance or resistor is the device or the component which plays a major role in allowing the current into the circuit. So the amount of current that flows in the circuit will be decided by the resistor, and the value of the resistor plays an important role in allowing the amount of current that can flow in the circuit. If you want more amount of current to flow in the circuit, see that the resistance is low. If you want to have a low current in the circuit, the resistance that should be applied in the electrical circuit should be high. So the selection of the resistance value will give us the amount of current that will be flowing in the circuit that we are connecting. Okay, so these are the basic types of resistors that are commonly used in any electrical or electronic circuits. So let's see all these things in detail. So the first one which comes under the fixed resistor is carbon composite resistor. So I'll just try to brief all the things. Okay. This kind of resistor comes under the category of fixed resistor. So these resistors are most commonly seen in any PCBs or any circuit boards or any in most of all the electronic circuits we find these kind of resistors. These resistors are nothing but carbon composition resistors. So coming to the main characteristics of this resistor, these resistor will have low inductance and these are very suitable for high frequency application. And coming to the manufacturing cost, these are very cheap to manufacture and also the cost is also very low. And coming to the tolerance value, these resistors will have high tolerance value. So all these features make these kind of resistors most commonly available and as well as common in usage. Okay, so these are the carbon composition resistors. Next one is film resistors. So these kind of resistors also come under the category of fixed resistors, and these are also the most commonly used resistors in any electronic circuits. So coming to the features of the film resistors, the resistance value of the resistor is controlled by increasing the desired thickness of the deposited film. So you can see here in this diagram we have two connecting leads. Inside the between the connecting leads there is a material. In that material there is some resistive film, and on the resistive film there is a spiral groove. This entire setup will be placed in an insulating material. Okay, so this insulating material is connected or placed in between the two connecting leads. So the resistance value of this particular resistor can be controlled by increasing or decreasing the thickness of the film, what we using it as resistive film. So the thickness of this resistive film will decide the resistive value of this resistor. So the resistance of up to 10 mega ohms can also be obtained in the film resistors. This is the advantage for film resistor. Higher values of resistances can be obtained in film resistors, and they have tolerance value of less, which is 1% or less. So these are the points regarding film resistors. Next one is wire wound resistor. As the name suggests, wire wound. So it is made by winding a thin metal alloy wire on an insulating ceramic former in the form of a spiral helix. So we just take an insulating material on which we just wound the wire. So that wire will act as a resistive material, and that entire setup onto which the two edges are connected to two terminals, that kind of resistor is nothing but wire wound resistors. So these resistors are available in very ohmic and high precision values, that is from 0.01 to 100 kilo ohms resistors are available in wire wound category. Okay, so in this diagram you can see starting you can see two connecting terminals. Next you can see a resistive metal wire which is wound on the insulating material. So the white one is nothing but the insulating material on which or insulating, or it is nothing but the former, ceramic former, on which resistive metal wire is wound. The amount of wire that we wound will decide the value of the resistor. Okay, so this is all about wire wound resistor. Next is rheostat, which comes under the category of variable resistor. So as you can see in the diagram, here there is a wiper kind of thing. This is this rod carries the resistive element or the conducting path. So when you move this wiper onto the on this rod, you can see a change in the resistance that you connect across these two terminals. Okay, so this kind of resistor is nothing but a variable or adjustable resistor. These are mainly used in applications that require adjustment of current or varying of resistance in any electrical circuits. Mostly these are used in controlling of AC DC motors and all. Okay, so where we want to control the speed by adjusting the value of this rheostat, you can vary the speed of the motors. There is a special kind of rheostat, and that is named as potentiometer, or simply called as pot. So you can see here I have shown you a pot or potentiometer. This is nothing but a 3-terminal resistor with a sliding contact that forms an adjustable voltage divider. As you can see it on the diagram, it is having 3 terminals, and by the adjusting sliding contact between these 3 terminals based on the voltage dividing property, the selection of the resistance can be made. So the potentiometers are commonly used to control electrical devices such as volume control, joysticks, etc. or simply you can see it in fan regulator, right? So you can select different speeds on in for a fan by selection of the regulator positions. So each position in the regulator will gives us a different speed for the fan. So there what we are using is nothing but the potentiometer. So these potentiometers are also used in knobs like volume control, speed control, or joysticks, etc. All the knobs in which when you rotate the knob, the value or the output is changing. Those kind in those circuits we see a device that is nothing but potentiometer. So potentiometer is the most commonly used variable resistor because it is small in size when compared to rheostat, and these are available in smaller ranges to very high ranges also. So coming to the symbol, so this can be used as a symbol for potentiometer. Next is thermistors. Thermo means nothing but temperature. As the name suggests, this is a type of resistor in which the resistance changes with the change in the temperature. Okay, so the concept is same, but there is no sliding of the there is no movement what we see for rheostat or potentiometer. Just with the change in the temperature, the resistance value will change. So thermistors can be used as current limiting devices for circuit protection as well as replacement of fuses. And coming to the symbol, we see this kind of symbol for thermistors. A rectangular box on which we give a diagonal line, and the other two edges of the rectangular boxes, two connecting terminals are connected. So this is nothing but thermistors, which is also a variable resistor whose resistance varies with the change in the temperature. Next is humistor, is a kind of resistor whose resistance varies with the significantly change in the humidity. So there is a relationship between resistance and humidity. When humidity changes, the resistance changes. So this is a kind of humidity sensor that measures the humidity level by measuring the change in the resistance of a element. So this is nothing but humistor, whereas thermistor changes the resistance with the change in temperature. Humistor changes the resistance with the change in the humidity. Next term is varistor. So varistor or voltage dependent resistor function is to conduct significantly increased current when voltage is excessive. So there is a relationship between voltage and resistance. So when there is the change in the voltage, the change in the resistance can be observed, and that kind of resistor is nothing but varistor. So this is a high voltage varistor which we commonly see in high voltage electrical lines. Photoresistor. So as the name suggests, photo, light. So the resistor whose property is based on light, that kind of resistor is nothing but photoresistor. So that is the resistor which is dependent on light is nothing but photoresistor. Photoresistor or light dependent resistor, we simply call it as LDR. So LDR or photoresistor exhibit photoconductivity. So photoresistors are used in many domestic items like street lights, radios, alarms, etc. Coming to the symbol, we see a rectangular box. On the two sides of the rectangular box, two connecting terminals are there, and this rectangular box is placed inside the circle, and outside the circle you see two incoming lines, arrow lines. So this shows that a light is falling on the resistive material, and the whole setup or the whole symbol symbolizes the photoresistor. So the resistor which changes its property based upon the light that is falling on it is nothing but photoresistor. Okay, these are the basic types of resistors which we commonly see in any electronic circuits. Depending upon the type of application, you can choose any of the above resistors. Like if you want to design a regulator or volume controller, you can go for a potentiometer. If you want to control the speed of motors, you can go for rheostats. And if you want to design any rectifier or filter circuits or any other basic circuits, you can go for fixed resistors, that is carbon or metal film resistors you can choose. So if you want high tolerances, you can go for carbon resistor, and if you want low tolerance value, you can go for film kind of resistors in the fixed resistor category. And knowing these points, we should also know how to connect these resistors in any electrical or electronic circuit. Coming to the connections of resistors, there are two basic connections of resistors. So knowing the connections of resistors is also important, because when you connect resistors in one fashion, value may increase, and you connect resistors in another fashion, value may get decrease. So the value of resistance will be dependent on the way you connect the resistors into the circuit. So based on the connections, in general any circuits can be connected in two fashions. First one is series connection and the second one is parallel connection. So series connection is nothing but, as you can see it on the screen, when one end of a resistor is connected to the other end of the resistor, that is one end. If we take 1, 2 as terminals, for example, the end of one terminal is connected to the starting of the next resistor, and the end of the next resistor is connected to the starting of the next resistor, then we call this kind of connection as series connection. So when you connect this kind of connection in any circuit, the value of resistance will increase. That is, in series connected resistor circuit, the total resistance will increase. If we calculate the resistance of the given circuit, the total resistance or the equivalent resistance can be written as R equivalent is equal to the sum of all the resistors which are connected in series. So the expression can be given as R equivalent is equal to R1 plus R2 plus R3 up to Rn. Okay, all the resistors which are connected in series will be summed up together to give us the equivalent resistance. So in series connection, what happens is the current remains constant, that is I is, so you see that the amount of current that flows in R1, R2 up to Rn will remains the same, as there is only single line of path for the passage of current. The current will remains the same. And coming to the voltage adds up here. Okay, so in series combination we can see that as current will be same, but the voltage in across R1 will depend upon the value of R1, and voltage in R2 will depend on the value of R2. So the voltage in R1 we denote it as V1, the voltage in R2 is denoted by V2, and voltage in Rn is denoted as Vn. So the current remains the same, but voltage drops will vary, and all the voltage drops will be added up to give the total voltage. So these 3 points should be kept in mind. That is, when we connect a resistor in series combination, that is end-to-end connection, if you make, the total resistance or the equivalent resistance of that circuit will increase, and 2 points, that is nothing but current remains the same, but the voltage will be added up to give us the total voltage. So these 3 points should be kept in mind regarding series connection of resistors. Next one is parallel combination of resistor. So this is purely the contrast version of the previous version, that is series connection. So parallel connection is nothing but when all the terminals of the resistor are connected to one point and the other all the points of resistor are connected to another point, that connection will gives us a connection called as parallel connection. This connection is also called as shunt connection. Okay, so you can see all the terminals here, R1, R2, Rn, all are connected to one point, and other terminal, that is this terminal, end terminal, all the end terminals of the resistor are connected to one terminal. This kind of connection is called as parallel connection. In parallel connection, the expression will be given as the equivalent resistance is given by 1 by R equivalent is equal to 1 by R1 plus 1 by R2 up to 1 by R1. In parallel combination, the voltage remains constant. That is, the same voltage drop we can observe across all the resistors, whereas the currents now here add up. That is, the reverse case happens here when the resistors are connected in parallel. So current will be adding up and the voltage will be the same. So based upon these 2 points, we can derive that and from the Ohm's law we can derive that 1 by R equivalent is equal to 1 by R1 plus 1 by R2 up to 1 by Rn. So this is all about the parallel connection of resistors. So these 2 basic connections show us that the value of resistance will increase when resistors are connected in series, and the value of resistance will decrease when you connect the resistors in parallel combination. So though the value of resistor may not change, but the connection makes the total resistance to increase or decrease. So it is not that easy that we always see that any of the connection is okay. That is not the thing. So every time when you connect resistors, you see that the total resistance is according to the circuit requirement or not. So if you want to increase one kind of connection, you can choose. If you want to decrease the resistance in the circuit, you can choose parallel kind of connection. So depending upon these points, the selection of the connection can be made. Okay. Next is the color coding. So as in the carbon and film resistors, which come under fixed resistor category, we have seen some I'll show you, wait. So in this carbon composite resistor and film resistor, we have seen some colors printed on the resistors. So what these colors indicate, now we will discuss. So the colors that are printed on the resistors are nothing but, or gives us the color coding value. So by knowing the values of the colors, we can give the value of the resistor. So just by identifying or knowing the values of the colors, we can give the value of the resistor. So that concept is nothing but resistor color coding. So the resistor color coding, as you can see it on the screen, in general in any resistor you find 4 different colors printed on it. Okay. So first one, for any resistor, to calculate the value of that particular resistor, we calculate the resistor like this. So the resistor value will be these four colors are nothing but bands. First band, second band, third band, fourth band. Okay. So what we write is that, so the first two bands, the first band is nothing but, we call it as first digit. The second band is nothing but second digit. Third band is nothing but the multiplier, and the fourth band gives us the tolerance. Okay, so you might have a doubt whether which side to be taken as a first band or the first digit. So which color is closest to the terminal or which band is closest to the terminal, start from that side. Okay, so when you observe a resistor, all the bands will be starting from one terminal. So bands will be closer to one terminal when compared with the other terminal. So start from that terminal. So those first two lines or first two band indicates the first two digits of the resistor. The third one indicates the multiplier. Fourth one gives us the tolerance. So all these bands will be of the same colors. Like we have colors like black, brown, red, orange, yellow, green, blue, violet, grey, white, gold, silver, and with no color also will have. So you have to keep it in mind, all the numbers or all the values which are given for the colors. So if you see black color coated on the resistor, that is, it is indicating a value 0. If you see brown color coated on the resistor, that means it is indicating value number 1. Okay, so all these numbers should be kept in mind for easy calculation of the resistance value. So all these values are fixed. Okay, so for example, if we have black color as second band and brown color as first band, then what we write it as, first band is brown color, then we write it as 1, and second band is black, so we write it as 0. Now the value is nothing but 10. And we have to write the third band. If the third band is nothing but red, if it is the third strip is in red color, the third strip is indicating the multiplier. So what we write is, the multiplication factor is with 10. So we write it as 10 power 2. Now as red indicates the value 2, what we write is, the multiplier term is now 10 power 2. So for the given example, brown, black, red. Brown indicates 1, black indicates 0. So 10, and the third band is red, that is nothing but 10 square. 10 into 10 square is the value of the resistor, that is 100 into 10,000, 1 kilo ohm resistor. So the fourth band in generally will be of the last three ones, either it may be gold, silver, or none. So if the tolerance value is 5%, then it will be of gold. If the fourth band is in silver, then the tolerance value is of 10. And if it is of no color, either there is no gold color or silver color, then we take the tolerance value as 15%. So for the example what I have told you just now, that is brown, black, and red. And if we take the fourth band as gold, brown, black, red, gold, for brown we write 1, for black we write 0, of the third band, that is red, we write it as multiplier, multiplying factor, we write it. So 10, the red number is given as 2, so 10 power 2. And the fourth band, now what we have taken is gold, so we write it as plus or minus 5%. So altogether, if we calculate the value of resistor, we get the value as 10 into 10 square plus or minus 5%, that is 1 kilo ohm plus or minus 5% is the value of this resistor what we have discussed just now, that the bands that is brown, black, red and gold gives us a value of 1 kilo ohm with plus or minus 5% of tolerance. So all these values are fixed and these values should be kept in mind: black, brown, red, orange up to white. So starting from black, that is from 0 to white, that is 9, these values should be remembered, and when you find the color you can simply write the number and that number will give you the value of the particular resistor. So as we are calculating the values of resistors with the help of colors, so this is called as color coding. So color coding of resistor, that is nothing but identifying the value of resistor with the help of the colors that are printed on it is nothing but the color coding of resistors. And next, coming to the power ratings of resistor, and it can be calculated by the formula that I have given here. So the power rating is given as P is equal to V into I, or otherwise it can be written as I square R, or it can be also written as V square by R. So what is the point of discussing the power rating of a resistor is, larger the power rating, the greater the physical size of resistor. Okay, so the size of the resistor will depend on the power rating of the resistor. So if the physical size of the resistor is more, that indicates that the power rating of that particular resistor is more. So when used in any AC circuits, the AC impedance of the resistor is equivalent to DC resistance. Okay, so these are the points, basic points which are to be kept in mind when dealing with resistors. Right. So till now what we have discussed is what is resistor, what are the different types of resistors, and in that we have discussed some basic features of different resistors that are available, and later we have discussed the connections pertaining to resistors. Then what is meant by color coding has been discussed, and finally we are concluding the session by knowing what is the power rating of any resistor and why we should know the power rating. So the size will describe the power rating of the resistor. Okay, so with this we'll conclude the session for today, and in the next coming session we'll discuss other points relating to resistors. Thank you.